In the circuit above, this circuit, if the EMF, electromotive force, is 9.0 volts, calculate the current in the circuit. Then we have options. Let's see if we can get one of these. Okay. So now if you have questions in circuit, there are things we need to take our time and solve. It's not something you go in haste. Now, the first thing you should know when we have components in the circuit is what are the components. So for this circuit, what we have here is only an EMF and an resistors with their different resistances. We have 3 resistors here with their different resistances. Okay, now after you have noticed that, okay, now for this circuit we have a resistance. The next step there is how to resolve circuits or how to resolve resistances of resistors in parallel and in series. You first of all have to know which are in parallel and which are in series. For example, for this circuit, R2 and R3 are in parallel. So the meaning is, if there is a current flowing from R2 to R3 or from R3 to R2, there will be a division of current. Okay, if it flows in this direction, if it comes here, surely to divide to this branch and this branch. If it is flowing from here towards any direction, there will be a division. So that means R2 and R3 are in parallel. Now, if these two are resolved into one, certainly they will be in series. Now, okay, let's start with that. We're going to start like this. If it is theory, you should go to work. R2 is parallel to R3. Okay, so these two resistors are in parallel. And if two resistors are in parallel, to get the equivalent of combined resistance, we use the formula 1 divided by R equal to 1 divided by R2, which is 5, plus 1 divided by R3, 20. Okay, so we solve this mathematically. 1 divided by R will be, the LCM the LCM of 5 and 20 is 20. So we place the LCM below. 20 divided by 5 is 4. 4 times 1 is 4. 20 by 20 is 1. Times 1 is 1. So that means 1 divided by R equal to 5 divided by 20. So what do we do here? We cross multiply. We cross multiply to make R the subject of the formula. Okay, if we do that, okay, let's proceed here. 5 times R is 5R. So 1 times 20 is 20. So divide both sides by 5. We have R. So 5 ohm resistor, 20 ohm resistor in parallel resolves together will have give us 4 ohm. Now, if it is an objective, you can just add this to 5 and continue with your solving. If it's a theory, you show good work to obtain your complete mark. So if we redraw this circuit, we have our first resistor here with its resistance of 5 ohms. Now, R2 R3 have been combined into one. So we now have one resistance for the two resistors, which is our 4 ohm. Remember, so we have another resistor here now. The value is 4 ohms. Then we have the circuit continues this way with our. Remember, we have an EMF from the equation. We said our EMF here is 9.0 volts. So we can represent here with 9.0 volts, which is our EMF or E. Now we go back to Ohm's law. Ohm's law says that a voltage flowing through a conductor is proportional to the current flowing through it. So then we have this. This can be V voltage. For this circuit is EMF, electromotive force. So let's replace and see what we have. And then from here, our I is equal to E divided by R. That is dividing both sides by R. If you don't want to do that, you can just go straight and substitute directly. Replace and see. Our EMF is 9.0. Sorry. Our EMF, electromotive force, is 9.0. Our current is what we are looking for. Our combined resistance is this plus this. 5 plus 4 are now in series, meaning if the current is flowing from 5 to 4 or 4 to 5, there is no branch anywhere. So our combined resistance here is 5 plus 4, which is 9. So we have 9.0 equal to I times 9. Okay, so we divide both sides by 9. So we have 9.0 divided by 9 equal to I times 9 divided by 9. So 9 will cancel 9. So the current flowing through the circuit is 9.0 divided by 9 is 1.0 ampere. The unit for current is ampere. Of course, you should know that, and it should include this. Now that means going through the options, B is the correct answer. So B here is 1.0 ampere. So that means in this cycle, if you have a cycle that has these 3 resistors and an EMF with their resistance is given. The resistance of this resistor is 5 ohm, resistance of this resistor 5 ohm, resistance of this resistor 20 ohm. So all of them resolve together 9 ohm. So if you have a cycle that has these 3 resistors, 2 in parallels with a magnitude 5 ohm, 20 ohm, in series with another 5 ohm, and an EMF of 9.0 ohm, our current flowing through that circuit is 1.0 ampere. Thank you. Please like, share, comment. It's a new channel. Support, comment, share. If you have any question, any part you don't understand, leave it in the comment section. Thank you. Bye.